Okay, so now we're going to take a look at solving one and two-step equations. So first we'll start with solving one-step equations. One step means there's only one thing you have to cancel out until you figure out the answer. An equation means a problem that has an equal sign and gives you the answer. So whenever the equal sign is there and the answer is present, what you have to do in order to find out the missing part or the value of the variable, the letter in the equation, is work backwards. You basically have to do opposite operations to figure out the value of that letter. So I like to put what I call a mirror down this equal sign, and that mirror just reminds me to do the same thing on both sides of that line. So the operation that exists right now here is multiplication, because a number right next to a letter signals 3 times x, or multiplication. So in order to cancel out that multiplication, I'm going to do the opposite, which is division. So since x is being multiplied by 3, I'm going to divide by 3 to cancel out that multiplication by 3. Whatever you do on one side of this mirror, you have to do on both sides of the mirror. So times 3 divided by 3 simply cancels out. 21 divided by 3 you solve, which is 7. X comes down because it was not canceled, and now you know x equals 7. If you want to check an equation, fortunately you always can have the availability to see if you were correct or not by taking the value of the variable that you found and plugging it into the original equation. So if you think x equals 7, then 3, instead of 3 times x, 3 times 7 should equal 21. 3 times 7 is 21. 21 equals 21. Therefore, you know you're correct. Now we'll take a look at an equation that involves division as the initial operation instead of multiplication. So here, fraction bar always signals division. It basically reads x divided by 5 equals 8. So the opposite of dividing by 5 would be multiplying by 5. I'll do times 5 on both sides of this mirror. Divided by 5 and times 5 simply cancel out. 8 times 5 you solve, which is 40. And your variable comes straight down because it was not canceled. X equals 40. Again, if I want to check the value of that letter, I should be able to plug in 40 in place of x in the original equation, and it should equal out to what the equation tells you. 40 over 5 equals 8. Ooh, I wrote 50 by accident. 40 over 5 equals 8. Well, 40 divided by 5 equals 8, and 8 equals 8, so I know I'm correct. Take a look at one more one-step equation, and this one involves addition as its initial operation. So as usual, I put a mirror down the equal sign. The opposite of plus 8 is going to be minus 8 on both sides of that mirror. Plus 8 minus 8 simply cancels out. 39 minus 8 you solve. 9 minus 8 is 1. 3 comes down. Equal sign stays in the same place the entire time. Variable has not been canceled, so it comes down. X seems like it equals 31. Let me check that. I should be able to plug in this value for this variable, and it should work out. 31 instead of x plus 8 equals 39. Well, 31 plus 8 is 39. 39 equals 39, so I know I'm correct. So those are one-step equations. Now let's take it a step further and look at two-step equations. This simply means you're doing the same steps, which is opposite operations on both sides of the equal sign. However, there are 2 steps. So what order do you perform those operations in? Well, typically when there's more than one operation in a problem, we follow PEMDAS. Parentheses first, exponents, all multiplication and division, all addition and subtraction. Since we're working opposite in an equation, you work in the opposite order of PEMDAS. You cancel out addition and subtraction before multiplication and division. So I'm going to cancel out this minus 8 by doing plus 8 on both sides of the equal sign. Minus 8 plus 8 simply cancels out. 7 plus 8, you solve. 8, 9, 10, 11, 12, 13, 14, 15. Equal sign stays in the same spot. 6/7 x has not been canceled, so it comes right down. Now, as usual, a number hugging a variable or a number pressed right up against the letter signals multiplication. So this actually means 6/7 times x. And the way I cancel multiplication is with division. So I will divide by 6/7 instead of multiplying by 6/7. on both sides of the equal sign. On this side, it just cancels out. On this side, we solve 15 divided by 6/7. Rules for dividing fractions say that I need to keep, change, and flip. I'll make this into a fraction. Change division to multiplication, 15 over 1. Change, flip to 7 over 6. And now multiplying fractions says multiply straight across. 15 times 7 and 1 times 6. 15 times 7, I'm going to do some scrap work on the side. 7 times 5 is 35. 7 times 1 is 7, 8, 9, 10. So this is 105 over 6. Of course, you want to reduce your final answer, so you put the top number in the house and divide. I'm running out of space here. 100, I'm going to do some erasing just so I could reduce. 105 divided by 6. 6 cannot go into 1. 6 goes into 10 once. 6 goes into 45 7 times. And the remainder is 3, 6, which could be reduced to 1/2. So 17 and 1/2 would be your final answer here. Now let's take a look at a two-step equation that does not involve fractions. So this one's involving decimals. Again, I have multiplication here, 4 and 7/10 times x, or 4.7x. I have addition here, plus 3.8. I'm going to cancel out each one of those, but I need to work in the opposite order of PEMDAS. So I'll cancel addition and subtraction before multiplication and division. So I will subtract 3.8 on both sides of this mirror. 2 minus 8 can't be done, so I have to borrow, and I know I'll have to borrow again. 12 minus 8 is 4. Decimal comes straight down. 12 minus 3 is 9. Here we go. 9.4, equal sign stays in the same spot. Plus 3.8 minus 3.8 simply cancels. 4.7x comes down. That's what we still have left. Now, 4.7x means 4.7 times x. So to cancel times 4.7, I will divide by 4.7, cancel, divide by 4.7. Variable comes right down. Instead of showing a long division problem with decimals, just in the interest of saving time, I'm going to plug that into the calculator. 9.4 divided by 4.7 equals a whole number 2. X equals 2. Now, if you want to check that, you should be able to plug in 2 in place of this original x in your original equation, and it should work out. 4.7 times 2 plus 3.8 should equal 13.2. Well, 4.7 times 2 is 9.4 plus 3.8 equals 13.2. 9.4 plus 3.8 equals 13.2. 13.2 equals 13.2, so I know I'm correct. 1 and 2 step equations.